Okay, so last class we had started with solution of differential equations by variable separable method, right?
Yeah.
Okay, so today I'll be dealing with the application of differential equations, and I'll be starting with exponential growth and decay problems. Okay,
Okay.
so let's start with exponential growth and decay problems. Okay. All right. So we'll begin with the question. The population of a country is growing at a rate proportional to its population. Okay, so there's a country whose population is growing at a rate proportional to its population. Okay.
Okay.
If the growth rate per year is 4% of the current population. Okay. If the growth rate per year is 4% of the current population, how long will it take for the population to double up? So I'll just write down the key data over here. Growth rate per year is 4% of the current population. Okay. And the question that they have asked is, how long will it take for the population to double? How long for population to double? Try this out. So they have actually given you the proportionality constant kind of a thing. For example, let's say if you take it as dp by dt, this was directly proportional to the population, isn't it?
Yeah.
The population is growing at a rate proportional to its population, and they have further clarified that this rate is actually 4% of the population. That means indirectly they're asking you to frame a differential equation like this. Okay?
Yeah.
Now, can we solve this? Can you move ahead with this hint?
Yeah.
So we'll separate the variables out, isn't it?
Yeah. So dp by p.
I can write it as
0.04.
dp by p is equal to 0.04 dt. Okay. Let me integrate both the sides. So it becomes ln p is
ln
equal
p
to
dp to 0.04 t.
plus c, correct? Now we'll assume that at time t equal to 0, the population was p naught. So let at t equal to 0 time, the population was p naught, right? This actually helps me to get the value of c. So this into, you can say 0, you can make this as p naught. So c is ln p naught, right? So I can again restructure this and write it as ln p minus ln p naught is 0.04 t. That means p by p naught, ln of that is going to be 0.04 t. So p by p naught is going to be e raised to the power 0.04 t. In fact, we don't need to do that because we need to find the time here. So let it be as such. And now the question wants us to find out the duration in which the population is going to double itself. That means I want what is the t at
P is
which
equal to 2 times p naught.
Absolutely, absolutely. So this is going to be 2 times p naught. So won't it going to be ln2 is equal to 0.04 t? So t is going to be 25 times ln2. Can you use your calculator to tell the answer for this?
Yeah. 17.3.
17.33 is correct. Are you getting it?
Yeah.
Chalo, we'll take another one. The bacteria in a certain culture increases continuously at a rate proportional to the number present. Okay. So there is a bacteria culture where the growth of the bacteria, the rate of growth is proportional to the number present. Okay. If the number triples in 6 hours, how many will be there in 12 hours? Is the question clear?
Yeah.
If the number triples in 6 hours, how many folds will the bacteria increase in 12 hours? So first, can you form the differential equation for this? So the number triples in 6 hours. How many will be there, or how many folds will it increase in 12 hours? Your physics paper is corrected.
Oh.
Shreya's physics paper is corrected. AP Physics. Yes, Shreya. What differential equation will I write first of all, stating the rate at which the bacteria is increasing? Let's say I denote
dt is
let's say I denote the number of bacteria at time t as n. So dn by dt is directly proportional to n. Correct?
Yeah.
Let's say the question was the rate at which the bacteria is decreasing is directly proportional to that present population. What will I write here?
If the number is?
If the number of bacteria, the rate at which the bacteria is decreasing.
Minus n.
Yeah, that's absolutely correct. So here if I have to remove the proportionality constant, I would put a k, and at the same time I need to keep in mind that k would be a positive term here. Is that fine?
Yeah.
Now I'll make use of again the variable separable method. Is that fine?
Yeah.
Let's integrate. So ln n is equal to kt plus c, and I'll assume that at t equal to 0, n is equal to n naught. Okay? Because we don't need to know what is the initial population, we just need to figure out what is the increase, or how many times the population has increased. Correct.
So n naught will be at 6 hours.
No. N naught is at t equal to 0. At 6 hours, it will be 3 n naught. At 6, n will be 3 n naught. Okay. Now I need these two conditions because I am not given the value of the proportionality constant, neither do I know my constant of integration. So these two will actually help me figure out what is my k and c. Make sense? So the moment I put t as 0, you would have realized by now that c would be ln n naught.
Yeah.
So I can say this as ln n by n naught is equal to kt Correct?
Mm-hmm.
Now k is still unknown, so what I'll do is I'll make use of the second situation. That means t is 6, n is 3, n naught.
So LN3 is KT.
Alright, so k is 1/6 of ln3.
Yeah.
Sounds good?
Mm-hmm.
I'll put it back here once again. So this will be further restructured as ln n by n naught is going to be 1/6 of ln3 times t. Is that fine?
Mm-hmm.
Now let's answer the question given to us. How many fold will the population increase in 12 hours? That means they want to know what is the ratio of n by n naught when t is equal to 12.
Mm-hmm.
So can I substitute here my t as 12, and when I do that I get 2 ln3, which is nothing but ln of 9. Now ln both the places are there. Okay. So I will okay. So basically, what is the conclusion? That the population will grow 9 folds after 12
Yeah.
hours. Makes sense? Are you getting a feel
Yeah.
of the flow of the
Yeah.
concept? Okay.
Yeah.
Great.
So there was this one particular question. It's not related to this. Can I just ask you,
Yeah, please.
or will it break the flow? Integral
Okay.
of 2 raised to 2 raised to 2 raised to x.
Okay.
No, so there are two 2's. Oh yeah, that one.
Like this.
Yeah.
2 raised to power 2 raised to power 2 raised to power x, right?
Yeah. Yeah.
Okay. How do we integrate this? That's what you're asking?
Yeah.
Okay. Take 2 to the power 2 to the power 2 to the power x as t. Correct? When you differentiate it, you have to use chain rule. So think as if there is 2 to the power something. So that will be 2 to the power something ln2 into the derivative of that something, which is again 2 to the power something ln2. Again the derivative of that something, that is 2 to the power x ln2. Okay. This would be your dt. Getting the point? So 2 to the power 2 to the power 2 to the power x into 2 to the power 2 to the power x into 2 to the power x times ln2 whole cube dx is equal to dt. Which means this required expression itself is nothing but dt upon ln2 whole cube, which is t by ln2 whole cube plus c, and just put your t back as 2 to the power 2 to the power 2 to the power x by ln2 whole cube plus c. This would be your integral for this question.
Okay.
Alright, so let's resume with the application, the growth and decay problems. Radium 226 decays. Radium 226 decays at a rate proportional to the quantity present. Now remember, the question says decays. It decays proportional to the quantity present. Okay. Its half-life is 1612 years. How long will it take for 1/4 of a given quantity of radium 226 to decay? How long will it take for 1/4 of radium 226 to decay? One quarter. Have you understood the question well?
Yeah.
Can you explain it to me in a simple word?
So, basically, the so what?
Let's say you start with n q naught. They're asking. Let's say you're starting with q naught amount of radium, and they're asking you when, after what time will it become 3/4 of q naught, right?
Yeah, so dq naught by dt is directly proportional to q naught.
No. dq by dt is directly proportional to q.
Oh.
Get the point?
Yeah.
By the way, here you can write kq and you can claim that k is a negative quantity in itself. That will automatically come out from the situation. Don't worry about that.
Mm.
So you can keep the proportionality constant as k. K will automatically come out to be negative. You don't have to put a separate external negative sign with k. Okay.
Mm-hmm.
Solve this.
Okay.
Hello. Which grade, sir? Second. Okay. Oh, is it? What happened, sir? I see. Okay. Okay. And any specific reason for that? Oh, I see. Okay.
Any idea?
Yeah. So yes, sir.
So doing.
What is this thing you want us to do? Okay. Can you just send me a mail, sir, of this? Okay, please send me. And if possible, please.
I don't get how the half-life is related to this.
Okay.
Because we had given a list of all those people.
Let me just help you out with this.
So now, because see, mostly you'll be asking the reason to us as well what happened.
Again, the story will be the
So
same.
you just drop in a text in the mail so that, and then we can start the call. It's contact us at centeracademy.com.
Yeah.
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 And I think by this time you would have realized that this is the structure that you're going to see. Correct?
Mm-hmm. Yeah.
Okay. Now see, the utility of this information that half-life is 1612 years is to find the value of k here. So that means they're trying to say that when q becomes half q naught, these many years have passed. Right?
Mm-hmm.
So after 1612 years, q has become q naught. Yes or no?
Yeah.
Okay. So when I put that value over here, I get ln half as k times 1612. That means k becomes 1 upon 1612 ln half. Now you yourself can see here that this would be a negative quantity. Just use your calculator, check what is the value for the k. I think it should come out to be negative 0.00043. Just check on your calculator.
Yeah. Minus. Okay. I got minus 4.17. It shows.
Ellen, did you take log to the base e only, right?
Yeah, I took ln 0.5. Yeah.
Okay, let me just check. Return.
Oh. Mm. 4.17 into 10 raised power of minus 4. Sorry.
1612. Yeah, it's 0.00042999.
Yeah, 10 raised power of minus 4.
Okay. Now, what is the question? The question is, what is the time that will go off? By the way, you can put this value over here. You can just put this back over here. So, ln Q by Q naught. That means you want this ratio to be 3/4, isn't it? And you need to figure out what is your T. So, T would be ln of 3/4 divided by negative 0.00043. Can you calculate this? This would be your answer. इसका चलता है check number 36.
Oh. Yes. Yes.
627 minus 627.
How is
0.9.
Okay.
minus 627? Yes.
Yeah.
Not possible. Check again.
I see. Okay. I see. Okay. मैम हमारी एकेडमी है सो वी रन एकेडमी एक्चुअली व्हिच इज allowed there only we
Check share once again.
Yeah.
Yeah, so it's not no we don't do in-house. We have a full-fledged academy where we prepare kids for multiple competitive exams.
No, so I'm getting the same thing. I don't know why.
I can do. I've done my calculator. I'm getting this.
It's if you're interested, we can take
637.2. Yo.
See basic.
What did you plug in?
Ln 3 by 4.
Yeah.
And then that divided by 0.
No, actually, we don't have
Just type ln 0.75.
We have a full-fledged, we say.
Oh, probably, yeah.
You would have done ln 3 by 4. You have done.
Yeah, that's right. Yeah, exactly. Round comes, yeah.
किसी को help कर देता हूँ just in case if anyone wants it. But I don't personally do a home teaching.
Okay. Next question is.
Yeah. No problem. No, good. I really don't know, मैम. मतलब मैंने कभी सुना नहीं है इसलिए मैं आपको बता नहीं सकता. Otherwise,
according to Newton's law of cooling. According to Newton's law of cooling. I mean, I will not tell you.
No, I understand, but then.
A hot object cools at a rate proportional to the difference between its own temperature and that of the environment.
So Saturday, Sunday, we have our.
So
for any other assistance, once in a while, I'm definitely there. But regularly, last year also we tried to do that, but because my schedule is very tight, so hence for it.
Okay. So I'm giving you a differential equation already.
This is in club room.
Okay.
Club room, that is our club room.
Yeah.
If a roast at room temperature.
Many people come from residency and all. Rainbow residency and all. Come here.
If a roast at room temperature 68 degree Fahrenheit is put into a 20 degree Fahrenheit freezer, is put into a 20 degree Fahrenheit freezer. And if after 2 hours the temperature of the roast is 40 degree, and after 2 hours the temperature of the roast is 40 degree Fahrenheit, then find what would be the temperature after 5 hours. These type of questions are called restricted growth, where there is a difference with a constant taken. Okay, so these type of questions come under restricted growth.
इसीलिए मैं अभी नहीं दे रहा था, अभी फाइनली प्रिंसिपल थिंग हाँ 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 एक्चुअली यू शुड हाँ ये कैसे निकाला निकलता है हाँ लगा ना फोन एक दो पर लगा ना रैंडम क्या चल रहा है सब कुछ चल रहा है
Question is clear, Shreya?
Yeah.
So question is there is a roast, right?
Mm-hmm.
Which is at room temperature, but it has been put into a freezer. So freezer is the new environment for the toast.
Yeah.
Okay, why did I write 20 here? I should have written temperature of the surroundings. I mean, this is the general Newton law of cooling. Okay.
Yeah.
So the rate at which the temperature drops is this.
Yes, Andrew. Yeah, I'm waiting for the class now. अरे जब लेके आ जाऊंगा फिर से जाऊंगा ले ले भाई अपना प्रॉपर्टी नहीं तो लगा अरे वापस उसके बाद गया तो दादाजी नगर में मार्कर ही नहीं था तो मैंने फिर मैं बोर्ड बोर्ड में लिखा है उनसे लिख दिया ले ले भाई ऐसा मत कर
What is the differential equation that you would write for this?
So give me 2 seconds.
Sorry?
2 minutes.
Yeah. Is it fine, Shreya?
Yeah, that's what I wrote. Yeah, that's what I wrote.
Can we do this then?
Yeah, I did that.
Can we integrate it?
Yeah.
What will I get? ln mod T
ln
minus
T
20.
minus 20.
You actually
is
did not
equal-
write mod because your temperature will never go below the temperature of the refrigerator. Okay.
So it's wrong to write mod.
Correct?
Is it wrong to write the mod?
No, it won't be wrong to write the mod. It's not required because you're already T minus 20 will already be positive.
Okay.
The freezer cannot make the temperature go below the sink temperature of the freezer, right?
Mhm.
So
Yeah.
how do I get the T and K? How do I get the K and C value? Can I use the fact that when T was 0, temperature was 68?
Mhm.
So at T equal to 0, temp was 68.
Yeah.
So can I say ln 68 minus 20, which is ln 48, is equal to C?
C. Yeah.
Right? That
Yeah.
means ln T minus 20 by 48 is negative KT.
Mhm.
Can I find the value of K by using the fact that after 2 hours T becomes 40?
Mhm.
Correct?
Mhm.
So K would be negative half ln 20 by 48.
Yeah.
Okay?
Yeah.
Can you tell me the value right now so that I can use it?
Mhm.
Yes, sir. Darya.
See you guys.
So 0.4375.
0.4377, correct?
75.
Chalo. I'll take it as 0.437. Okay. We are disagreeing on the fourth decimal place, so we'll keep it till 3 decimal place.
Okay.
Hey, iska teacher on. Teacher on is on. Okay. Yeah. So going back to this point, ln T minus 20 by 48 is going to be negative 0.437 T. Okay. Now, what is the question asking me? The question asking me what is the temperature after 5 hours? So I need to know what is T after 5 hours. So T minus 20 by 48 is going to be e to the power negative 0.437 into 5, correct?
Yeah.
So can I directly compute from here itself? That is 20 plus 48 times e to the power negative 0.437 times 5.
Yeah.
What is the answer that it gives out?
Just so is it 25.376?
Yeah, they say approximately 26 degree Fahrenheit. Okay.
Yeah.
Acha. Part 2 of the same question. How long will it take for the temperature to fall to 21 degree Fahrenheit? So what is the time when the temperature has fallen to 21 degree Fahrenheit?
Sir, 8.85.
Approximately
Yes.
9 hours, what they say.
9
That's
hours.
correct. That's correct. So you can just put your t here at this point with 21, right?
Yeah.
So 1 by 48 will be equal to negative 0.437 into t. So your time would be, if I'm not wrong, it would be ln 48 divided by 0.437. That's roughly 9 hours. Okay.
Mhm.
So let's take another question. Advertisers generally assume that the rate at which people hear about a product is proportional to the number of people who have not yet heard about it.
So could you repeat that?
Was it too fast?
Yeah.
Okay. Advertisers generally assume that the rate at which the people hear about a product is proportional to the number of people who have not yet heard about it. Okay.
Okay.
Suppose that the size of a community is 15,000. Okay.
Mm-hmm.
That to begin with, no one has heard about the product. Okay, so there is a community of 15,000 people, and none of the people in the community has heard about the product.
Okay. Yeah.
But that after 6 days, 1,500 people know about it. So when 6 days pass, 1,500 people in the community hear about the product.
Mm-hmm.
Okay. How long will it take for 2,700 people to have heard of it? So what would be the t value for 2,700 people to hear about the product in the community?
Mm-hmm.
And this time you are going to give me the differential equation that is going to be
So the differential equation is dh by dt is equal to k times 15,000 minus h.
uh, absolutely correct. So you can say dn by dt is k times, where n is the number of people who have heard about
Heard it.
Heard
Yeah.
about it, yeah. So it's k times 15,000 minus n. Absolutely correct. So it's a case of restricted growth.
Mm-hmm. So the number of people in the community remains the same, right? It's the same
Yeah,
community.
15,000 is fixed.
Yeah. Okay.
Is that fine?
Yeah.
So what is the integral of 1 by 15,000 minus n?
So 1 second, I'm just almost done. Just give me.
Okay, sure.
So is the answer around 6 days?
So 6 days
No.
it is almost
I got
1500.
5.9. I don't know
No,
why.
that's wrong. So when you integrate it, what do you get, Shreya?
Okay, I get ln of 15,000 minus h, okay fine, n is equal to kt plus c.
That's not completely correct. There would be a minus sign over it.
Why?
Because the coefficient of n is -1. So you have to divide by -1 as well.
Oh.
Okay? Now, at t equal to 0, how many people had heard about it? None of the people, right?
Yeah.
So I can use the fact that t is 0, then n is 0.
Yeah.
So I'm assuming n is the number of people who have heard about it,
Mm-hmm.
who have heard about the product.
Yeah.
Right?
Yeah.
So I'll get C is equal to negative ln 15,000.
Okay.
Cool?
Yeah.
I place it back over here. So I get ln, correct me if I'm wrong, ln 15,000 by 15,000 minus n is kt.
Mm-hmm.
Is
Okay.
that fine?
Yeah.
Now, how do I get the value of k? By using the information that after t equal to 6 days, 1500 people had heard about it.
Yeah.
So use at t equal to 6, capital N is 1500.
Yeah.
So ln 15,000 upon 13,500
500
is equal to
to
6k.
6k.
So you can just cancel off. I think you can divide by
15.
15. You can divide, of course.
Yeah.
So 15
1 by
will
9.
be ln 10 by 9.
10 by 9.
Yeah, ln 10 by 9 is just 6k. So k becomes 1/6 of ln 10 by 9. Is that fine?
Mm-hmm.
Well, now coming to the requirement of the question was asking me how many days will it take for 2,700 people to hear about the product?
Yeah.
So, can I write it like this into t,
Yeah.
right?
Yeah.
Okay, so I'll make things a bit simpler for you. ln, what is this term going to be? 1,500 by 12300, right?
1, 2, 3. Right.
Correct.
Mm.
So it's ln 10 by 9 to the power of 1/6 into t. It doesn't make much of a difference though, because you have to ultimately divide.
Yeah.
So 1/6 ln 10 by 9. But what we can do is you can just cancel off this. 5, 6, you can go by a factor of 3, 41. So your answer will be 6 times ln 50 by 41 by ln 10 by 9. Can you calculate this, T?
Yeah.
I'll also help you out. So 6 times ln 50 by 41 divided by ln 10 by 9. I'm getting 11.3.
I got 11.2. Oh, yeah, same thing. Yeah.
So book says 11 days approximately. Is that fine?
Yeah.
Now we'll take a case of logistic growth. Logistic growth is basically a type of growth where the rate of change of the quantity is proportional both to the amount of the quantity and to the difference between a fixed constant and its amount. Something like this. dy by dt is directly proportional to y into some fixed value minus y. Okay, these type of problems are categorized under logistic growth. Logistic growth questions. So we had seen exponential growth, we had seen restricted growth, and this is logistic growth, where the rate of change of the quantity is directly proportional to the quantity as well as a fixed quantity A minus the instantaneous quantity.
Okay.
Understood?
Mhm.
Let me take up a question related to logistic growth. Question is like this. Because of limited food and space, a squirrel population cannot exceed 1,000. Okay?
Mhm.
It grows at a rate proportional to both. It grows at a rate proportional both to the existing population and to the attainable additional population.
Attainable additional population. Okay.
Okay?
Mm-hmm.
If there were 100 squirrels 2 years ago, and 1 year ago the population was 400, how many squirrels are present right now?
Okay.
Is the question clear or should I repeat it again?
No, I got it. So it doesn't necessarily have to be a minus y, or it can be a plus y as well.
It has to be a minus y. Difference of a fixed constant and the amount present at that time. See, 1,000 is the maximum attainable, right?
Yeah.
So let's say at a given time the population is P, then this is the attainable additional population. You can attain this much more. So what it is given is that dP by dt is proportional to P into 1,000 minus P.
Yeah.
That is both to the existing population and
The
the
additional population.
attainable additional population. You can attain 1,000 minus P more.
Yeah.
And it's also given that 2 years ago there were 100 squirrels. 1 year ago there were 400 squirrels. Now what is the number of squirrels present right now?
Yeah.
So let's say your time began at 2 years ago. So 2 years ago T was 0. 1 year ago T was 1. And this was 2 years ago.
So now your t is 2.
1 year ago. And now your T is 2. This is now.
how will you integrate dp upon p into 1000 minus p?
Very good question. Have you done partial fractions before?
Oh, partial fraction.
By the way, you would have removed this proportionality constant with a k, so I'm
Yeah.
writing it over here.
Okay.
You can actually just take care of it by doing 1 by p plus 1 by 1000 minus p, correct? And you do 1 by 1000 down over here. That's how you can break up 1 by p into 1000 minus p. Isn't it?
Yeah.
Right? Now, instead of integrating this, I can choose to integrate this with respect to p,
Yeah.
right?
Yeah.
So that's going to give me
ln p 1 by 1000 ln
Right.
p
ln p. What about
Plus-
this? Share.
plus ln of 1000 minus p
And again, you're making the same mistake. Who will divide with
divided by
the minus
1
Yeah.
minus 1.
So kt plus c. So you can directly say 1000 of ln p upon 1000 minus p. That's kt plus c for you. Now, how do I get the value of c? What was the situation 2 years ago? When t was 0, what was p? P was 100,
When p was 0, p was 100. Yeah.
right?
Yeah.
So can I say 1000th of ln 1 by 9 is equal to c?
Yeah.
Yes or no?
Yeah.
Okay.
Mm.
So I can put that c back over here. So I can write this as 1 by 1000 ln p by 1000 minus p minus ln 1 by 9 is equal to kt.
Yeah.
Yes or no?
Yeah.
So I can say ln 9p by 1000 minus p is equal to 1000 kt. Is that fine?
Yeah.
Alright. Now what else is given to me? When t is 1, p is 400. Right?
Yeah. Yeah.
So ln 3600 divided by 600 is going to be 1000 k. So k is 1000th of ln 6.
Yeah.
Right?
Yeah.
Okay. So if you put this back over here, what does the equation convert itself to? It becomes ln
ln 9p by 1000
minus p
minus p
is equal to 1000 kt is nothing but ln 6 times t.
Yeah. Yeah.
Now they ask me what is p when t is 2. So ln 9p by 1000 minus p is going to be 2 ln 6, which is nothing but ln 36. Now just compare the term within the ln's. So compare 9p by 1000 minus p is 36.
Okay. Yeah.
So can I say 45p is going to be 36,000?
Mm-hmm.
What's the value of p? $36,000 upon 45. How much is that?
800.
It's 800 squirrels. Presently, there. Is it fine? So one last question we'll take before we call it the completion of this chapter. So we are done with differential equations, and we are going to begin with the chapter which you are waiting for. Okay. So let's take one last question on differential equation. Suppose a flu-like virus is spreading through a population of 50,000 at a rate proportional both to the number of people already infected and to the number still uninfected.
So could you repeat that?
Okay. Are you not able to understand my American accent?
Yes, sir.
Okay, I'm so sorry. Let me come to Bengaluru accent. I see what is happening here is the rate at which the flu is spreading is directly proportional to the number of people infected and the number of people still not infected. And the population is 50,000. So basically what they're trying to say is this. So again, it's a case of a logistic growth, right?
Yeah.
Now the question is clear.
Yeah.
If 100 people were infected yesterday and 130 are infected today, determine how many will be infected a week from today.
So 200 people today, right? That's what you said.
No, 100 people were infected yesterday.
No, I'm saying about today.
100 infected yesterday. 130 people today.
130. Okay.
130 are infected today. Why I'm writing S after everything? Okay. Question is, determine how many will be infected a week from today. So yesterday was t equal to 0. Today is t is equal to 1. A week hence will be t is equal to 8.
Yeah.
Solve this.
तो फिर आप पुश करोगे, जल्दी आओ। हाँ, श्रेया है क्या?
Yeah, Shreya, Mr. Dheeraj wants to talk to you.
Hey, Shreya.
Hmm? Yes, sir.
See, I have still to correct your question paper, but whatever I have corrected,
Was pathetic.
huh?
Was bad.
It is getting recorded. Don't say such things.
No, I'm asking. It's okay.
It is not as expected. Okay. So, can we discuss it completely tomorrow? It will be better.
Tomorrow, as in we have a class today.
Yes, as in today's class can be had tomorrow. That's what I'm saying.
Cool. Okay.
Tomorrow, what time?
The same time one.
Same 8 to 10 you want?
Yeah.
Take it. Okay, fine. It can't be earlier?
Mm, okay, fine. Tomorrow will be 6. I don't know about Akhil sir because I don't know when Akhil sir will.
Yeah, no, you fix up your time. I can work around it. No worries.
Okay, fine. Then I think 6 o'clock will be fine. 6 evening.
6 to 8. Okay, 6 to 8. Fine. You still continuing till when?
Last question. Correct, Shreya?
Yeah. So 1 by 50,000 in integral 1 by n minus 1 upon 50,000 minus n. Yeah. 1 upon 50,000 ln n minus ln 50,000 by n minus 1. Okay. Equal to E plus C.
Right? So now we have been given that when t was 0, that's yesterday, 100 people were infected. So
It was not 1,000 people?
No, it was just 100 people. Huh? I wrote here, no, 100 infected yesterday.
Oh, I took it as 1,000.
Just 100 people. Okay.
Mm-hmm.
So, if I'm not wrong, the value of C would come out to be 1 upon 50,000 ln 100 divided by 49900, correct?
Yeah.
That's going to be 1 upon 50,000 ln 1 by 499. Okay?
Mm-hmm.
So, when I put it back in this equation, I get 1 upon 50,000 ln, and this will get subtracted, so it becomes 499n by 50,000 minus n. This is equal to kt.
Yeah.
Correct?
Yeah.
Now t equal to 1, n should be 130.
130, yeah.
So k will be 1 upon 50,000 ln 499 times 130 by 50,000 minus 130.
Yeah.
Can we calculate the value of k right now? At least this part I can say it's coming out to be 0.26
Yeah.
9 by 50,000. We don't have to calculate the value exactly because we would need it over here again. Okay.
Oh.
So the question was asking how much would be infected after a week from now. So it would be ln 499n by 50,000 minus n is equal to 50,000 kt. 50,000 kt is 0.626290.
Okay.
And put your t value here as 8.
Okay.
So 499n divided by 50,000 minus n is 8 times this. How much is that?
8 times.
2.103. Correct?
Yeah.
So the answer that you're going to get would be, I'm just writing the direct result, n would be 50,000 into 2.103 divided by 501.103.
Okay. So is the answer 2.03?
2.03. No. Why will it be so less?
Fifty thousand into 2.0. Wait, what? Is that 501.10?
Yeah. It's 501.103.
That was multiple. Okay.
I just recalculated.
209.83.
I just again calculated. Shreya, just give me a moment. 130 divided by 49870. Yeah, that's correct. So into 8 will give you 2.103. Absolutely correct. Oh, I have to do e to the power this also. Oh, I forgot e to the power this. Just make some slight change over here. This value I'll recalculate once again. E to the power this will be e to the power 2.103 will be 8.19. Yeah, now just recheck. The answer would be n would be 50,000 into 8.19 divided by 507.19. So 50,000 into 8.19 divided by 507.19.
807.
Yeah, answer is 807. Okay. So with this we come to the end of the differential equation chapter.
So one question.
Yeah.
What are the key words for this type of question, as in how do we make out whether
Logistic growth. Logistic
again
growth.
from the question.
Yeah. If you see your exercises that I have sent to you,
Mm.
you would come across this term called logistic growth and all. And moreover, the wording of the question itself will suggest what is the differential equation you are supposed to frame.
Okay.
Okay. You'll say the rate is dependent on the current population and some fixed constant minus the current population. That is logistic growth question. Restricted growth is where you say some fixed constant minus the population or population minus some fixed constant. Exponential growth is where they will just say it is directly proportional to the population. Are you getting it?
Yeah.
In all these three cases, try to appreciate the difference in the graph. How will be the population dependent on the graph? Okay. So a simple task I would give you, just try to see how is the graph getting changed in case of exponential growth, in case of restricted growth, and in case of logistic growth. Because many times they will ask you the graph of it also.
Okay.
Okay. So do that as a homework. Tomorrow's class, after Dheeraj sir fixes your time with you, I will.
So 6 to 8, right?
6 to 8 tomorrow. Okay, so I'll take from 9 to 10.
Night.
Yeah?
Night?
Yeah, night.
Okay.
That would be fine with you?
Yeah.
Okay?
Yeah.
Okay then, thank you. Bye-bye.
Yes, sir. Bye-bye.